Welcome to qnawire.
All right, the question asks, what is the effect on the EMF of the cell shown in figure 20.9, which has the overall reaction Zn solid. So here's my reaction. I'm just going to write this up here so we can refer back to it. So I have zinc solid plus a 2H plus, and that's aqueous, yields Zn2 plus, aqueous, plus H2 gas. All right, it asks what's the effect on the E cell for a bunch of changes. So what we want to look at here is we want to be looking at, it's helpful to look at the Nernst equation. So remember, this is going to be E equals E naught minus, I'm going to do the one that it includes the log of Q. So this is 0.0592 divided by N log Q. And this is the equation that's at 298 Kelvin because none of the conditions talk about an increase in temperature, so I don't need to worry about temperature changes. So the first change that they want to make to the system is that the pressure of H2 gas, so the pressure of my H2 gas is increased at the cathode. So the other thing we want to kind of look at here is our equation for Q. So remember, Q is products over reactants. In this case, I have a concentration of Zn2 plus is one of my products, and a pressure of hydrogen gas is another product. And then the solid zinc doesn't factor in here, but the concentration of H plus, and that's going to be squared, does. So this is what I'm looking at for my Q. So if I increase the pressure, I'm increasing the value of Q because the pressure is in the numerator. So I'm going to be increasing my value of Q. If I'm increasing my value of Q, then this value here is going to get bigger. And since E is equal to E naught minus that, if this part goes up, the overall E cell goes down. So I'm going to have a lower overall EMF of the cell for this change. In part B, the change is that zinc nitrate is added to the anode half cell. So I'm adding some Zn2 plus essentially. So if I add Zn2 plus at the anode, okay, so my concentration of Zn2 plus is increasing, is essentially what that's saying. So I am again increasing the numerator of Q. So Q is now again going to increase, and then for the same reason as E did before, if Q increases, the EMF cell decreases. In part C, I am adding sodium hydroxide to the cathode half cell. So, and it says that the H plus is going to decrease because the OH minus here, this hydroxide part, is going to react with the H plus. And if it reacts with the H plus, that means it's going to it's going to form water. So thus decreasing my concentration of H plus. If I decrease the concentration of H plus, the H plus is in the denominator. So as the denominator goes down, Q again goes up, right? And as we stated before, if Q increases, then the EMF decreases. Finally, in part D, I say the surface area of the anode is doubled. So the surface area, so like we're looking at a greater surface area of zinc, but the zinc doesn't come into play because it's a solid, so it doesn't really matter that the surface area is increasing. Surface area might affect the kinetics of the reaction, but it's not going to affect the Q or therefore the E. It doesn't affect the N factor. Nothing else is changing here. So there is going to be no effect by increasing the surface area of our anode.